All right, let's do a quick review of solutions. On the top here we have our equations, which will be given on the test. Let's look at some vocab. Solute, the stuff getting dissolved. For example, if I dissolve salt into water, salt is the solute and water is the solvent. Now, usually solutions, the solvent is water, but you can dissolve stuff in alcohols or gasoline or something like that, turpentine. Saturated means that you have a maximum amount of solute. Any more will just sink to the bottom if you put it in there. Rate of dissolving, how can you increase the rate of dissolving? That is that you could crush up or powderize or your solute. You could stir it, that helps to dissolve stuff faster. You could heat it, in most cases, that makes it dissolve faster. Let's see, what else? You could add solvent, add more water, and it will make stuff dissolve faster. Concentration is a measure of solute to solvent, and there's different ways to do it. You can do it in molarity, moles per liter. You can do it in parts per million or parts per billion. You can do it in percents. Those are all ways of measuring concentration. We'll review those here in a second. Dilution, when you add solvent, a solution becomes more diluted. The concentration gets smaller and smaller on there. This equation right here is the equation for dilutions. Let's look at that in more detail. This equation describes dilution. For example, I have a beaker with a certain amount of water and a certain amount of solvent in it. It has a certain concentration. So the concentration initial and volume initial. If I multiply concentration times volume, concentration is measured in moles per liter and volume is measured in liters. So when you multiply them, you'll get moles. So that'll tell you how many moles are in this, concentration times the volume. If I add some solvent and make the solution have a larger volume, but still have the same number of moles in there, then I have a diluted solution. The volume increased, the concentration decreased, but when you multiply concentration times the volume, you still get moles. So the number of moles that were in the original thing is going to equal the number of moles after it's diluted. So you could have a concentration before and a volume before, a concentration afterwards, and a volume afterwards, and you may have to calculate one of those unknown things there. So if you had a solution with a certain volume and a certain concentration, and then you create a new volume, what's the new concentration, for example? Something like that. That's what that formula is about. This concentration is measured in what we call molarity or molar concentration. Molarity or molar concentration in moles of solute divided by liters of a solution. Moles of solute divided by liters of solution. Now, another way to do it would be to measure parts per million. For parts per million or parts per billion, you're going to take the number of grams of solute divided by the grams of solution. Grams of solution. All right, for example, if I had a solution that was made by, taking so many grams of NaCl and putting it in here, and then I end up with a solution that has so many grams, then I would take the grams of the solute divided by the grams of the solution, and I'll get and then times a million, it turns it into parts per million. Parts per million. You could do the same thing, but instead of multiplying times a million, you multiply it times a billion, and you'll get parts per billion. You could have parts per 100, and that would just be grams of solute divided by grams of solution times 100. parts per 100. So parts per million, parts per billion, parts per 100 is the same thing as what we call percent. Parts per 100 is percent. There's a couple of ways of using percent for measuring concentration. And the percent by volume, you would take the volume of the solute, stuff getting dissolved, divided by the volume of the solution, and times 100 makes it a percent. Or you could do a percent by mass, and then you'll use the grams of solute and grams of solution. So there's just a couple of different ways to do it. This is a solubility or a saturation graph. Each one of these lines tells you the saturation point. For example, at 50 degrees, the maximum amount of, say, KNO3 that you could dissolve would be about 85 grams. Now, that depends on how much solvent you have, so that's on 100 grams of water. So at that temperature, this would be a saturated solution if it had 85 grams. If I tried to put, say, 90 grams into the solution, well, 85 grams will dissolve, and then the extra 5 grams will just sink to the bottom. Right, it'll sink to the bottom. If I increase the temperature, now I can get more to dissolve. Any graph that's sloping up. In some graphs that slope down, the hotter it is, the less dissolves. There, so that's what this is. It tells you the saturation point for any solution. It's a saturation line, which depends on temperature, and it depends on how much solvent you have too as well. All right, let's look at acids and bases. Acids are chemicals that generally have an H in the front of their formula. Bases are chemicals that have an OH, usually on the backside of their formula. When you dissolve acids, you always make H plus ions. When you dissolve bases, you always make OH minus ions. We call those hydrogen ions and hydroxide ions. The difference between acids and bases. Now, when these H pluses dissolve in water, they always hook up with another water molecule, and they turn into H3O plus ions. So the H plus ions don't really float around freely in the solution. They always hook up with water and turn into hydronium ion. It's the concentration of that hydronium ion, or H plus ion, that we use to determine pH. So pH is actually a measure of those things. We didn't really go in full detail of that, but the concentration of these this ion is what we mean by pH, and it has to do with logarithms and stuff like that. So if you take the logarithm, then that's how you get pH, all right, the negative log. All right, but we're not going to do that on the test. What you need to know is that pHs less than 7 are acids, pHs greater than 7 are bases, pHs equal to 7 are neutral, and pure water is neutral. Sometimes instead of calling it a base, we call it alkaline, just an adjective. If we call an acid are acidic and bases are alkaline. pH of 7 is neutral, sometimes called pH balanced. The actual numbers come from taking the negative log of the hydrogen ion concentration. All right, don't need to worry about that just now. But so because it goes by a logarithm, which is on a base 10, each one of these numbers is a power of 10. So if I go from 3 to 5, I change the concentration by 10, 100. 100 times more concentrated in hydrogen ion if I go this way, say. All right, what else about acids and bases? We learned a bunch of properties of acids and bases. There may be questions related to this. Both of them are corrosive. Acids taste sour. Now, it doesn't mean you could just taste any acid. It could wreck your tongue. Bases taste bitter. Acids add hydrogen ions, which then turn into hydronium ions. And bases add OH ions to the solution. There's indicators. One of them is called litmus, and in acid it's red, in bases it's blue. pH is less than 7 are acid, pH is greater than 7 are base, or basic, or alkaline.